So I'd like to talk to you today about some RPGs that I'm using in my introductory astronomy class. So for those that don't know, RPG is short for role-playing games. So the options and purposes of these games to decide if you might want to use them in your class. So students take on roles in a variety of kind of science adjacent challenges, and the games are all designed for non-science liberal arts students. They're appropriate for middle school through high school. I suppose you could adapt them to elementary school if you wanted as well. Each game comes with pre and post quiz assessments, so you can know if they're learning what you want them to learn. And all materials are hosted on a Google Services website right here. And the link is in the description as well. Now, the purpose of these games isn't necessarily to have students know and understand really complicated science concepts really well. The main purpose I have is to improve student opinions towards science. And in that sense, the content kind of takes a back seat to interaction. And what I've done is I found this particularly useful for virtual or COVID delivery, where I have no clue what my students look or sound like until we started playing these games. So the first game we play is called Mission to Mars. And this is based on Mars 1, which was kind of a business formed to kind of send people to Mars and to fund it by turning it all into a reality show. So this is the idea that we're doing here. Students are given 3 goals. They want to arrive on the planet, survive, and thrive. And they have 2 ways that they can pick their astronauts. They can use science. Now the science has been written up and drawn from official NASA documents for how they select astronauts, and it requires the students to do a decent amount of reading, versus media. So I've created some media trailers, found some media trailers online, and kind of jazz things up and make it exciting and interesting and fun to watch to kind of get the media side of who should be chosen to be astronauts. And students get to choose whatever motivation they want in making their decisions. Each astronaut gets a point value that goes towards these 3 goals of arriving, surviving, and thriving. Okay? And oftentimes, the right scientific choice is at odds with the right media choice. And students kind of have to pick which one they want to do. I kind of made some adaptations to this. Originally, it was to do kind of ethical decisions based on science. Is it right to send people on a one-way trip to Mars? I've kind of adapted it in light of current kind of environment that we're in to kind of have students look at whether they should look at science and trust the scientists, or if they should trust kind of the media spin on who is chosen to be astronauts. The idea behind this challenge then is to get students to think more deeply about believing science over media. Next game we play is Galileos Trial. This is the first kind of real game. We relived the 1633 heresy trial of Galileo. I've separated the students into 3 factions. The Holy Rollers represents the church, the Science Geeks kind of represents Galileo's scientist faction, and then the Average Joes represent the average person at the time, and they serve as a jury to decide who wins. Each of the 2 factions, the church and the scientists, they have characters that actually present, that have to present some science-based reasoning or some church-based reasoning for why they say what they say. And students are only allowed to use period-specific knowledge. Okay? And they're questioned by the opposing factions and the jury who represent, the common folk. So what do students get out of this? Well, there's 4 characters that do presentations. The Pope, Ptolemy Jr., great-great-grandson of Ptolemy, talking about geocentrism. Galileo talking about heliocentrism, and Copernicus. And they present scientific arguments, or in the Pope's case, he presents kind of Catholic biblical reasoning for why he says what he says. And the students fight with each other. I encourage them to yell at each other. If we're in person, I encourage them to throw paper at each other. It just makes it more fun and more interactive. The content that I get out of this game, not always the best content. But what I do get out of this is the students get practice with doing presentations, practice with challenging each other, and talking about science in kind of a fun, interesting way. Now, a bonus that's not in the abstract is a new game that I just tried this semester. I tried it a couple weeks ago called Planetary Panic. So what is this? It's pointing out that Earth is poised to be much less pleasant in the next 100 years or so because of climate change. And I wanted them to kind of think about this and what they could do about it. And they had to come up with an evidence-based approach for how to settle one of these 4 areas. Now, I did this mainly to kind of appeal to our own students here at Marymount. We have a very large fashion program, so one of the tasks was to design an evidence-based spacesuit that met their needs of their settlement. So kind of like a Project Runway version of doing some science. Kind of engaged my fashion majors a little bit more. And then they had to create a PR campaign and or a smear campaign against the other groups to say why their settlement is the best or why the other settlement is stupid. And this is kind of to appeal to our business and marketing population of students, get a lot of business students that kind of take the class. If they rank this assignment, so you can see the rankings, gave them a just general scale with 1 being horrible and 5 being awesome. So we had 2 people that kind of thought average, 7 were like, oh, this is okay, and 14 were like, oh, this is great, they loved it. So it's a popular kind of way to teach the students, and they really seem to enjoy it and engage with it. Next game that we're playing is Solutions to Climate Change. So what is that? We used to do a game where we'd argue about climate change if it's real or false. That seems completely and utterly useless to me now. We need to stop doing this balancing of both sides. That's insane, especially in the case of climate change. It is a scientific fact. Climate change is happening. We don't need to debate the science behind that anymore. So I want to make that very clear for my students, because this is probably the last and only science class that they will be taking. So I make that point that the science is clear. No reason to argue about if it's happening or not. The place where we can debate, though, is the solutions for climate change. And that's what their goal is in this assignment. So I based it around a Project Drawdown, which is an evidence-based approach to figuring out how to solve climate change. And they've kind of quantified the effect of different aspects. So electric cars, electric trains, electric bikes, replenishing wetlands, all sorts of solutions on this Project Drawdown website. And students get to work in groups, pick the solution that they want to research, and present on that. This again gets them more time with presentation and debate skills, and there is a selection of jury students that grill them with questions. So again, getting them used to interacting, getting them used to talking to each other, actually seeing them on Zoom calls and hearing them on Zoom calls. And then the last one is the Great Debate. The Great Debate, kind of think of this as the kind of overarching final test of if they learned anything in these debates. They relive this Great Debate of 1920, which attempted to explain the very nature of the universe. So this comes at the very end of the semester after we've covered everything to do with space. We've covered planets, stars, galaxies. So they have all the prior knowledge they need to present scientific arguments. Okay, they're going to argue about fuzzy patches in the sky, whether they're inside of our own galaxy or if they're galaxies all of their own. Okay, these 2 groups they present in front of a group of professional physicists and astronomers, and they all get very detailed roll sheets telling them exactly what they need to present and how they need to present it. So this really is forcing them to kind of read some science and apply what they've learned to understanding these kinds of historical scientific documents. It's a real challenge for them. They have to be real scientists. And here I do start to emphasize you need to get the content and the context right. So this is a nice scaffolded way to build up and assess if they actually learned anything, learned how to present science, and learned how to read some science as well, and get them actually fighting with each other too. So those are the games that we present. Let's see some clips of how each of these games work.
So, I'm being accused of heresy. On what grounds? I'm being accused of heresy on the grounds that I said heliocentrism is correct. There are no grounds to call me a heretic, because I never explicitly said that heliocentrism is correct. In my work, Dialogue Concerning the Two Chief World Systems.
Okay, it sounds like you're just projecting at this point. You're saying all these things, but you don't have any actual proof or fact, and you're just laying on this idea.
Excuse me? Excuse me? God is our proof.
How can you prove that?
Telescopes, but I haven't seen a telescope. The church hasn't seen a telescope. This courtroom hasn't seen a telescope. So what are you talking about? Okay, but you haven't seen God. You haven't heard from God, and he says he's heard from God, but like you don't have any proof that he's actually heard anything from God. So what do you learn about in church then? You think you can make that up? That's all these words, man. Like you don't have any actual proof that it's true, do you?
So a lot of you are probably familiar with the fact that Australia was used as a penal colony in its very beginnings of civilization there. We have kind of the same idea, but for Venus, and I will explain a couple of reasons why.
And it's the Death Star. What more do you want? So yeah. We're going to have a very not evil at all greenhouse floor. Nothing bad about it. It's just growing food. Definitely not doing anything bad there.
For protective measurements, being out in space, there's a lot of things that could go wrong. Mostly objects are going to be hitting us, so we're going to be equipped to hit any objects coming from any direction. Usually small objects are going to be, incinerated. For the bigger collisions, we're going to just try and move out of their way, or just try and position ourselves using the thrusters. And there's going to be an artificial atmosphere so that, we can handle the pressure. It's not just the lack of, gas up in the vessel. So it has to have a thick enough atmosphere that can, sustain us.
So here are some quick statistics for you guys. These come from a couple of different sources, both textbooks that I have, as well as some sources that my group members found. Let's talk about how meat is the largest culprit of emissions, energy use, and overall resource use in the world and in our country.
And this is taken right off of Home Depot. And you'll see two interesting things. The top one, which is incandescent, it's called a 65-watt bulb. That's how much energy that bulb will take up. And at 65 watts, it's producing 620 lumens. A lumen is a measurement of light, or the amount of light that comes out of a bulb. 1 lumen is about 1 candle, which I don't know what the last time or when the last time you used a candle was, but let's just say 620 lumens, fairly bright.
An example of energy saving within these LED bulbs is actually in Brazil. Many of you may not know I'm a dual citizen and I go to Brazil often, and I have seen the switching of LED bulbs in person